Welcome to Section 10, Lesson 4. Multiplying and dividing radicals follows two clean rules, the product rule and the quotient rule. Both let you combine radicals before simplifying, often producing perfect powers that disappear at the end. The product rule says the square root of a times the square root of b equals the square root of a times b. Two separate radicals collapse into one with a single radicand. The same holds for cube roots and any higher index, as long as both indices match. The quotient rule says the square root of a divided by the square root of b equals the square root of a over b. Division of radicals turns into a single radical of the quotient. The denominator must be non-zero. The strategy is always the same: combine first, simplify second. Combining often exposes a perfect square or perfect cube under the radical, which simplifies to an integer or a much cleaner expression. Simplifying first usually wastes work. Take the product square root of 3 times the square root of 12. Apply the product rule, combine into the square root of 3 times 12, which is the square root of 36. 36 is a perfect square, so the answer is 6. Now a quotient, the square root of 50 divided by the square root of 2. Apply the quotient rule, combine into the square root of 50 divided by 2, which is the square root of 25. 25 is a perfect square, so the answer is 5. When the radicand after combining is not a perfect square, simplify it as a regular radical. The square root of 6 times the square root of 8 equals the square root of 48. 48 has the perfect square factor 1640. 8 equals 16 times 3. So the answer is 4 times the square root of 3. The graph below shows a sanity check on the product rule. The square root of x times the square root of x equals x. A parabola squared by itself becomes a straight line. The two functions overlap exactly, confirming the rule visually. Example 1. Multiply 2 times the square root of 3 by 5 times the square root of 12. Both factors have a coefficient outside the radical and a number under the radical. Multiply the coefficients separately and the radicands separately. 2 times 5 is 10. The square root of 3 times the square root of 12 is the square root of 36. Simplify the radical. Square root of 36 is 6. The expression collapses to 10 times 6. Multiply 10 times 6 equals 60. The number line below shows the answer at 60, a clean integer result, even though the original expression had 2 square roots in it. Example 2. Divide the square root of 75 by the square root of 3. The square root of 75 is irrational on its own, but when divided by the square root of 3, the radicand becomes a perfect square. Apply the quotient rule. Combine under one radical square root of 75 divided by 3. Simplify the inside. 75 divided by 3 equals 25. The expression is now the square root of 25. Take the square root. 25 is a perfect square. Its square root is 5. The number line shows the answer at 5, while the original square root of 75 sat near 8.7. Combining first turned an irrational divisor problem into a clean integer. 3 takeaways for multiplying and dividing radicals. They generalize cleanly to higher index roots. The product rule says square root of a times square root of b equals the square root of a times b. Both factors must be non-negative and the same index must match between the two radicals. The same rule extends to cube roots, fourth roots, and beyond. The quotient rule says square root of a divided by square root of b equals the square root of a divided by b. The denominator's radicand must be positive. Division of radicals turns into a single radical of the quotient. The strategy is to combine first, then simplify. Combining usually exposes perfect power factors that the original separate radicals concealed. Simplifying each radical first wastes effort and often misses the cleaner combined form.